Welcome to RM-Tuner. Today we will learn how to use the adaptation table, the RM-Primis Autotune feature. Hi, welcome to this video tutorial. The Autotune works by looking at the target AFR and the current measure AFR. It compares both, and it generates a correction value that when applied to the VE table, it brings the measured AFR closer to the target AFR. You will find the adaptation table on the tuning menu, next to the other tables. This one you see on the screen is the fuel table, also known as the VE table. VE stands for volumetric efficiency, and it's your main table to control the amount of fuel going to the engine. And this one is the target AFR table. Our goal is to get the measured AFR close to the values set here. This one is the desired ratio between air and fuel. This is the adaptation table, or Autotune, if you prefer. It's important to understand that when the engine is cold it takes 2048 cycles for this to start, and when the coolant temp is above 70 Celsius it takes 1024 cycles to start working. The Enable button will turn on the adaptation table. After it's on, the computer doesn't have to be connected, it will run and save in the memory. The upper and lower limits will limit how much correction can be generated at once. You will see that as the times goes on, this corrections will start to be tiny, and you will be able to reduce this values. It's important to understand that after the cells get to the limit, they will not increase any further. They will get the maximum allowed and stop, and if more correction is needed, you either have to apply to VE to zero the table or increase the limits. The constant load time acts like a filter. It sets the minimum amount of time that the engine load reference, MAP or TPS, have to be stable so a sample can be taken and a correction can be calculated. This will help not to trigger corrections when not needed, and it makes the system more stable. A higher value will cause less corrections, and a lower value will trigger corrections more often. Now the priority. You can see this as a speed knob. The higher the priority, the more correction it will try to do per engine cycle. Lower numbers will result in smaller correction and smoother correction also. If your priority is set too high, you will see big correction factors everywhere. This is not the goal. Last but not least, the apply to VE. The ECU will calculate the corrections and apply them to the fuel calculations in real time. But if you want to make them permanent, or if your cells are all maximized to the limits you set up, as seen before, you have to apply the correction to VE. This will apply the corrections to your fuel table, like we see here. It will zero the whole adaptation table, like we just watched, and allow the system to learn any other corrections that might be necessary. Hopefully with time the correction factor will be lower and lower, indicating that your engine is running closer to AFR target. Let us know if there is any other topics you want covered in video. Thanks for your support.